Yes.
All right, so 3G today. The next couple of lessons, we're going to be talking about translating and reflecting, and then we're going to be going on to dilating. So different ways of moving our graphs around our Cartesian plane. And we did do some of it in year 11, but we're looking at it again. Some of the equations that we're going to be doing, if they're simple translation ones, you might be able to do them intuitively, but there are some little formula type things here that you can use to help you, which I'll be showing you how to use in these examples. Okay, so if translation means that we're going to be moving our graphs from either side to side horizontally or vertically up and down, and reflection is what it says, to reflect it across the x-axis or the y-axis or both. Okay, so if we are going to shift something horizontally to the right, to do it algebraically, what we're going to be doing is we're going to replace the x's in the equation with x minus h, h being the number of places that you want to move it to the right. If you're going to move it to the left, it would become an x plus h. Does that make sense? Okay. If you are wanting to shift your equation vertically, upwards is the positive direction, which means that we're replacing the y with y minus k. So we're using k for our variable for that one. And if we're going to go down, what do you think I'd replace it with? Y plus k. Absolutely. If I want to reflect a graph on the y-axis, it means you're wanting to replace your x values with negative x values. So you're moving it from the positive side, you want to reflect it across to the negative side, or vice versa. And if you're reflecting on the x-axis, it means that you're going to replace y's with positive y's, reflect over the axis. And if you're going to rotate 180 degrees about O being the origin, that means you're reflecting across both the x and the y-axes. So you're replacing x with negative x and y with negative y. You're doing both of them. Okay, so it will become a bit more intuitive as we go through it, I think. Write down the equation of the resulting graph when each transformation below is applied to a circle. So our circle's equation is x minus 2 in brackets squared plus y plus 1 in brackets squared is equal to 1, and we want to draw a quick sketch of our new circle once we've found it. So if I want to shift my circle 2 units to the left, keeping in mind all those rules that I've just given you, I want to replace, now because I'm moving it left, that's across the x-axis, it means I'm replacing the x with, now be careful, it said left. So which way should I go? It should be a plus, that's right. So with x plus 2, because I'm going to the left. So I'm going to rewrite my equation with, everywhere where I see the x, I'm going to replace it with an x plus 2. So it'll be x plus 2 minus 2 in brackets squared plus y plus 1 in brackets squared equals 0. Now this is a fairly intuitive one because plus 2 minus 2 just becomes 0. So it's x squared, y plus 1 in brackets squared equals 1. Okay, you might have been able to do that one without having to do the substitution. But anyway, let's draw that. Our circle has a center. Hopefully you remember how to read these off. Whatever's in the brackets is where the center is. Because there's no longer a bracket around the x, that means 0 would be the x and the y would be at negative 1 for the center. The radius is 1 as well. Good. So x and y, my center is at 0, negative 1, which is going to be right there. And a radius of 1 going all the way around from that. So 1 up, 1 down, 1 left, and 1 right from the center gives me, well, that's a bit wobbly, but it should be a circle from there. Okay? Let's do part B. We're just doing one shift at a time. We're going to shift up this time. So am I replacing the x or the y?
Y.
Y. So I'm going to replace y, and I'm moving up. So what should I replace it with? I'm going to do -3 for 3 spaces. So putting that into my equation everywhere where there's a y. So the x stays the same, x minus 2 in brackets squared, plus, instead of the y, it'll be y minus 3, and I still have the plus 1 in brackets squared, is equal to 1. And obviously inside that bracket for the y, I can collect up y minus 3 plus 1 would be y minus 2 in brackets squared. So where is the center of my circle? 2, 2. Okay? And a radius of 1 again. So I'll move that down a little bit to have enough room. So 2, 2 can be there. And a radius of 1, 1 up, 1 down, 1 left, 1 right. And there's my circle. Yeah, okay, ready for the next one. We're not ready for the next one, we're going too fast. We're okay? Question C, I want to reflect in the x-axis. So reflecting in the x-axis means we're kind of going across the y-axis, which means we replace the y with -y. So let's put that into our equation. X stays the same, so it's x minus 2 squared, plus, then I'll have -y plus 1 in brackets squared equals 1. Now, we never have a minus sign in front of our y when we're reading off the center of the circle. So I need to bring that minus out as a factor. If I bring the minus out as a factor, it would give me a y take away 1 squared inside that bracket. So I'm taking a not minus sign out of both of those terms. And I would be bringing a -1 out the front, but I have to square that because that bracket is squared, and a -1 squared will become a plus again, so it just becomes that. Okay, does that make sense? Yeah, so you bring the minus factor out, but you square that factor to make still a positive in between the two brackets. So really all it has done is change the sign of the y and the 1 inside that bracket. Okay, so what is the center of that circle?
-1, 1.
Nope. 2 and +1, x value first. So 2 for the x value, +1, 1, 2, +1. So 2, 1 is the center there, and a radius of 1, 1 up, 1 down, 1 left, 1 right. And put a few numbers on there so that markers can see that you've done the right radius the whole way around. And part D, we want to rotate about 180 degrees about the origin, which is when we replace the x with -x and the y with -y. Okay, so let's write that out. That will be a -x minus 2 in brackets squared plus, and then bracket minus y plus 1 in brackets squared equals 1. Now I have to bring that minus out of both of them. So if I bring the minus out of the first bracket, it would become an x plus 2 in brackets squared. And because I'm squaring the negative that I'm bringing out, it still stays positive outside that bracket. Do the same thing for the next one. Bring the minus out of the bracket. So it'll make y minus 1 in brackets squared, and then it's equal to 1. What's the center?
-2.
Yes. -1, -2, and 1. So center is -2, +1. one up, one down, one left, one right, and we have a nice circle. Okay, not too bad? Everyone following along? Okay, so that was a circle. Now we're going to choose a different type of graph and do some similar things. Question 2, it says write down the equation of the resulting graph and then when each transformation below has been applied to the exponential curve, y equals 2 to the power of x, and draw a quick sketch. Okay, so you could do this with any of the types of graphs that we know. So I've just chosen the circle and the exponential, but it could be hyperbolas, it can be parabolas, it can be lines, all those fun things. Okay, so this first one, I want to shift it down 2 units. So down is in the vertical direction, that's the y. So I'm going to replace the y with what? With, yes, plus 2, good.
That's right.
Okay, so let's put that into the equation. The y is on the left, so it's going to be y plus 2 is equal to 2 to the power of x. But we normally like the y by itself, so it's y equals 2 to the power of x minus 2. And that's how we're used to seeing it. We're used to saying if I want to move my exponential down, I just put the minus 2 on the end. But that's why the plus 2 works, because that's when I sub it in, it's on the left-hand side.
Can we go straight to that?
Yeah, you could. So that's what I said. If you can do these things intuitively by moving it down, by knowing how we can do that, it works fine for like shifting up and down. It's pretty easy. Left and right for some graphs is pretty easy. The reflections can be and rotations can be a bit more confusing. All right, so let's draw that. The exponential curve. Hopefully, remember the basic shape of it. The minus 2 means that my asymptote has been moved down here to be at minus 2. So horizontal asymptote at y equals negative 2. An exponential, well, maybe I'll draw over here the basic one for you. The starting graph would have looked like that, and it would have gone through a 1 with my horizontal asymptote on the axis. So by moving it down, where's my y-intercept? At minus 1, good, in there. And what is my x-intercept?
1.
It will be 1. So if you're in doubt, you could sub 1 in. 2 to the power of 1 is 2. Minus 2 makes 0. Okay, so there's my intercept right there at 1. So it comes up like that and goes very, very steep, very, very fast. Next one, I want to shift up 3 units. So I'm replacing x or y? Y again, because I'm still doing it vertically. But this time with, what am I placing it with? Yes, minus, because I'm going up. It's always the opposite direction in my mind. So if I'm going up, it means I want minus. If I'm going down, I want a plus. So subbing that in, I will have y minus 3 equals 2 to the power of x. And of course, move the 3 across, and we get what we expect, 2 to the power of x plus 3, which means my horizontal asymptote has been moved up to positive 3. Horizontal asymptote at y equals 3. There's not going to be an x-intercept because my whole exponential is going to be above it. Where's my y-intercept going to be? At 4, 1 space above. Okay, to show the steepness, I could sub in another point. So I would sub in 1. 2 to the power of 1 is 2, plus 3 is 5. So that would be that there. And it would come up like that. So I've moved it up, I've moved it down. What's next? Part C. Oh, I should write that point on there, sorry. 1, 5. Part C, I want to reflect it in the y-axis. What am I replacing this time? Replace. Yes, good. All right, so into the original equation, that would give me y equals 2 to the negative x. What does that do? Well, we know it reflects it. So it means that instead of my exponential going up slowly, it's going to be starting high and coming down. but the horizontal asymptote stays in the same place. I haven't moved anything vertically. So horizontal asymptote at y equals 0. My intercept, have I moved that? No, so it will be at 1. It's just reflecting so that it's going to start steep on the left-hand side. So let's get a value. If I sub in -1, it would be 2 to the power of positive 1, because the minus would be 2. So it'll be steep up here on this side, or steeper, and then it's going to come down like that. Okay, and then D, to rotate 180 degrees about the origin, that's when we replace both of them. Replace x with negative x and y with negative y. So in the equation, that will be negative y equals 2 to the power of negative x. You would move the negative sign from in front of the y across to the other side. Dividing by a minus would give you negative 2 to the negative x. The horizontal asymptote has not moved. Still here. So the first reflection would have been the one that I did in part C, but then it's going to be reflected down. So it's going to be steep down the bottom left-hand quadrant and come shallow up the other side. Where's the y-intercept? -1. Sub in a value just to show the steepness. So at -1, I have 2 to the power of a -1, so 2 to the positive 1, which is 2, but then with a minus sign in front of it, it will be down at -2. So -1, -2 is down here, y-intercept at -1, and it's coming up like that. And I can label that point -1, -2. All right, so that's our first type of questions where we're going to be moving things around.